Okay. Looking at number 11. So these were where it gave us a certain amount of zeros. So if there were any zeros that had square roots or i's, we needed to add the other zeros that, if like positive 3i is a zero, that also means negative 3i is, right? If 6 plus the square root of 2 is a zero, so is 6 minus the square root of 2. So if it gave us one of those zeros, we needed to add the other one too, because it's automatically a zero, then turn those into factors and do all the foiling, okay? We did one of those on Monday, so that's what we're gonna start with on number 11. It says, find a polynomial function of the lowest degree that has the given numbers as some of its zeros. So let's see, it gives us the zero square root of 3, and it also gives us the zero of 3i. So if the square root of 3 is a zero, then automatically what else is a zero? Negative square root of 3. If 3i is a zero, then negative 3i is also a zero. So we know that there are those 4 zeros. Now remember how we went backwards. We turned the zeros into the factors that they would have come from. And those are always just x minus whatever the zero is. So this one would be what? X minus the square root of 3. This one would turn into, it would come from x plus the square root of 3. And then turn these into their factors, x minus 3i and x plus 3i. Now from here, we did all this foiling, okay? Now remember, if you have the conjugate factors, which means factors that are the same except for their signs in the middle, you want to multiply those together, right? So these two are conjugates of each other. So I'm going to multiply those together. These are also conjugates of each other, right? They're the same with different signs in the middle. So I'm going to do these two together, then these two together, which will give me 2 answers that I'll then have to multiply together. Okay, so let's FOIL here. My first, x squared, right? X times x is x squared. Now, we did some of these in support. Remember how we talked about what happens when you multiply conjugates together with that and that, the outers and the inners? What's always going to happen to those?
They cancel.
That's exactly right. They're going to cancel each other out. So if you're thinking about doing FOIL, the outers and the inners, if you're doing conjugates, are just going to cancel each other out. So essentially, all we really have to do are the first, and then where can we jump straight to? The last. So we don't even have to do the whole FOIL, right? And that's only when the 2 parentheses are conjugates of each other. That's when the canceling is going to happen in the middle. So I did x times x to get x squared. Now, just in our head, on the outer, I'd have positive x squared root of 3. On the inner, I would have the opposite of that, right? Negative x squared root of 3. So I'm not even going to do those. I'm going to do the first, x times x, and then I'm going to jump straight to the last. Negative square root of 3 times positive square root of 3, which gives you what? Negative square root of 9. What can I rewrite this as? What is the square root of 9? 3. It's plain 3. So I'm just when I multiply all this together, I'm just left with x squared minus 3. I'm going to do the same thing, multiplying these together. Since they're conjugates also, I'm going to skip the outer and the inner part of FOIL. There's no reason to do it. They're just going to cancel each other out anyway. So I'll do my first. X times x, which gives me x squared. And then I'm going to jump straight to my last. Negative 3i times positive 3i is negative 9i squared. But remember, what is I squared always? What do I always turn that into? What is I squared?
Negative 1.
1. So this turns into what? X squared. Since this is negative 1, it turns this into x squared plus 9. So that foiling, those two together, actually kind of cleaned us up a little bit. Now we just have this left to multiply. These are not conjugates of each other, right? Which means I do have to do the outer and the inner because they're not going to cancel each other out. So my first x squared gives me x to the 4th.
Or x quadruple.
I never thought about it like that. What's my outer going to give me? X squared times positive 9. This gives me positive 9 x squared. My inner, negative 3x squared. And then my last, negative 3 times positive 9 is negative 27. Can I clean that up? Are there terms that you can put together here? Right. Those middle terms, they are both x squared, so put those together. So you have x to the 4th, 9x squared minus 3x squared, so you just have 6x squareds. Bring down the minus 27. All right. Number 12. All right, this starts something a little different. The polynomial function has the given 0. Find the other zeros. So let's see. The function that they give us. F of x equals x to the 3rd plus 7x squared minus 2x minus 14. And it tells us one of the zeros is negative 7. And it wants me to find the other zeros, okay? Since it's x cubed, since I have one of the zeros, I'm looking for 2 more. If you are given one of the zeros, you can use, remember when we did this synthetic division? Where we use this, if that's a 0, I can use synthetic division. I'm going to show you a couple of different ways to find other zeros. Remember what you put in here, the coefficients of this function, which would be in front of x cubed is a 1, in front of x squared is a 7, in front of x is a negative 2, and then the constant is negative 14. Now, when I do synthetic division, it's telling me that that's a 0, so I should end up with no remainder at the end there, right? That's what makes it a 0, is ending up with no remainder over there. So let's see. I drop down my 1. Then I multiply negative 7 times 1. Put your answer there. So negative 7 times 1 gives me negative 7. If I add this straight down, I get a 0. And then do it again. Negative 7 times 0. Put your answer there, which is 0. And add this straight down. Negative 2 and 0 is negative 2. Negative 7 times negative 2 gives you what? 14. So you do get a remainder of 0. So that tells me negative 7 is definitely a 0. It told us it was. But now I'm going to use this right here to find my other zeros. When I do synthetic division, these numbers represent what is left over as a polynomial function with starting with 1 degree less than this. Which means the first term, this is its coefficient, so the first term instead of being 1x cubed is going to be 1x squared. Going down from there, so plus 0x minus 2. Look what you have left. What is an x squared called? What do we call that all the time? Quad. If I'm finding zeros and I have a quad, I can use my quad program to find the other 2 missing zeros. So then you're just going to go to your quad program. So program down to quad. And type in your A, B, and C. What's A?
1.
1.
0, negative 2.
Good. B is 0. And my constant is negative 2. Enter. Weird decimal. Enter again. There's your other 2 zeros. Since that's a 0 right there, 0 plus the square root of 2, you don't need to write, you can just write square root of 2 and negative square root of 2 are your other 2 zeros. All right, number 13 is pretty random. I'm going to go ahead and tell you this won't be on a quiz or a test or anything. This is the only problem you're going to see like this. So I should probably take it out.
Oh, it's not going to be on the test?
It's not going to be on. Have you looked at it yet?
No.
All right. P of x equals x squared, x to the 4th plus 27x squared minus 324. I is 0. Now, I can't do what I did last time because this is an I. I can't do synthetic division with an I. But if 6i is a 0, what else is? That's also a 0. Just stay with me on this one. Remember, just one problem. So, if those are both zeros, let's go backwards and turn those into their factors that they came from. Because, you'll see why. This right here, what would have been its factor that it came from? X minus 6i. This one would have been x plus 6i. The reason I'm doing this is because if I multiply those together, they're conjugates, first of all. I'm not going to have an I in my problem anymore, and you'll see why. First, x and x is x squared. My outers and inners are going to cancel, right? Because they're conjugates. So I can jump straight to my last. Negative 6i times positive 6i is negative 36i squared. Here's why my I situation is going to go away, because what's I squared? Negative 1. So this really says x squared. What does that turn this into?
36.
Plus 36. So that is one of the factors of that polynomial function, right? I use the zeros to get it. Here's what I'm going to do with this now. I'm going to use long division to find the other two factors. Here's how I'm going to write that. I'm going to divide this polynomial function by this factor. I know that it goes in there evenly. It's a weird situation, but I know it goes in there evenly because it came from the two of the zeros of that function. So I'm going to have x squared plus 36, and I'm going to divide that using regular long division. We have not done this. Into here.
I haven't done long division in forever.
Right?
I always know about long division.
So we're going to have to also probably remind ourselves of the rules of long division, even though we're throwing in a weird problem.
Weird problems are part of long division.
Yeah, they are. Weird. Long division is just weird. So here's the first step. When you're doing long division with x squareds and x's and all that, you want to look here and here. Remember, where does the answer of your long division problem end up? With whatever's up here, right? That's going to be your answer. So I'm going to divide, I'm going to say x squared goes into x to the fourth how many times? The way I like to think about it is, what do I need to put up here to multiply times x squared to make it x to the fourth? So in other words, x squared times what is x to the fourth? Exactly right. X squared times x squared. Now remember, in the long division, when you put the first thing up here, you multiply it times what's here, put your answer there, and then you subtract it. So let's see, what's x squared times x squared? X to the fourth. What's x squared times positive 36?
36 x squared.
Good. Now, the long division rule says I subtract this from here, which is going to actually that's going to get rid of my x to the fourth, right? Because what's x to the fourth minus x to the fourth? 0, nothing. This, since I'm subtracting, this really says 27x squared minus 36x squared. So what's 27 minus 36? Negative 9x squared. This comes down. Do the same thing. You want this to be able to cancel this out. So what do I need to multiply x squared by to make it negative 9x squared? No, just negative 9. Right, watch, because here. If I multiply this times both of these, what's negative 9 times x squared?
Negative 9x squared.
Negative 9x squared. Negative 9 times positive 36. If you multiply this in your calculator, it gives you negative 324. What do? I subtract this. Negative 9x squared. This turns this into Positive. So what happens to your x squareds? They're gone. What is it? What does this minus turn this into?
Positive.
Positive. So negative 324 plus 324. There's your remainder. Where's your answer? X squared minus 9, which is quad. I can use the other factor to find the other two zeros, right? If I did the division and got x squared minus 9, but I'm looking for zeros. I'm not looking for the factor. I'm looking for zeros. Put that in your quad. So quad. What's A? What's in front of x squared? 1. What's B? Be careful. 0. Good. What's C? Negative 9. Enter. What are your other two zeros? Negative 3 and 3. Now, remember, the only zero that it gave me in the problem was 6i, right? It told me that 6i was a 0. That's the only one it gave me. It asked for the other zeros. And when I was doing this at home, just to making sure I remembered how to do it, I kept putting in this as my answer and it kept marking it wrong. I was like, I know it's right. What's the other zero that I'm missing? It only told me this one. That one, right. Those are the other zeros. One problem.
You
said we don't have to do this problem no more.
Right.
Thank goodness.
If you want to just forfeit that problem on your homework, and it won't be on the test request. Number 14 and 15. Gives you a function. P of x equals 22x cubed minus 36x squared plus 42x minus 15 and it wants you to find all the possible zeros, rational zeros. This is kind of an old school way, right, to find, remember what zeros are. They're the x-intercepts or the solutions, the zeros. Those are all interchangeable words, right? The old school way to start, before I had a graphing calculator and I could put this in my calculator and see where it crossed the x-axis, the way that you would have to start to find all the possibilities of things that may be x-intercepts, use this method. Using this number first, and this number here. You would list all the ways to multiply to get 15, which would be what? 15 times 1 and 5 times 3. So those are all the factors of 15, right? So all the factors of the last number. Do the same thing with the first number. These numbers don't mean anything. All the factors of 22, which will be what? 22 times 1, and how else do you get 22? 11 times 2. The way that you would start finding all the numbers that could maybe be an x-intercept would be the plus and minus of this number over all of those. Yeah, this is just the start of it. Which would be plus and minus what? 15 over 22 plus and minus 15 over 11 plus and minus 15 over 2 plus and minus 15 over 1. What's 15 over 1? It's just 15, right? So you don't really, so this one, since it's 15 over 1, you can just do plus and minus 15. Then, do it with the 5. Same thing. So plus and minus 5 over 22 plus and minus 5 over 11 plus and minus 5 over 2 and plus and minus 5 over 1. And what is 5 over 1? 5. So plus and minus 5. I'm only going to do one of these. You're going to use this example to do 14a and 15. Do it again. With the 3. So, what's the next one? Plus and minus 3 over 22. Plus and minus 3 over 11. Plus and minus 3 over 2, and plus and minus 3 over 1, which is 3. And this is a multiple choice problem, right? You're not going to have to type all this in. And the last one. Now what am I going to do? 1 over all those. So, plus and minus 1 over 22, plus and minus 1 over 11, plus and minus 1 over 2, and plus and minus 1 over 1, which is 1. Okay, so the old school way, that's how you would find all the possibilities of the zeros. You know what you'd have to do from there if you were actually going to find the zeros? Use synthetic division with those numbers over and over. Doing synthetic division with this to find the ones that would give you no remainder. That's a lot of work.
So we do the ones on the end.
So the ones on the number on the end is this side. The number on the beginning is this side. You don't care about that. You find all the ways to multiply to get that number on the end, to get its factors. Do the same thing with the first number. Then use this side, starting with the first number, put it over all those. Move to the second number, put it over all those. Do it again, do it again. But yes, this right here is always, has to be the last number. If not, you'll get your numerators and denominators flip-flopped. So always the last number actually comes first. Yep, 14 would be A. Yeah. So you're going to use that same example to do number 15, right? So again, you would do, on 15, you would do the 5 first. 5 times 1 would be your factors, and then do the 16. on the other side. Ooh. All right, number 16 says find all the rational zeros and the other zeros, if there are any, from this polynomial function. F of x equals x to the third minus 57x plus 56. Now, what I like to see is quad, right? Because if I'm finding zeros and it's x squared, I'm just going to jump straight to my quad program to find the zeros, right? This one's not quad yet. So my first thing is, what if I put this, what are zeros? They're the x-intercepts of the function. If I can do one round of synthetic division here, I will be left over with a quad, right? Because if I'm starting with x cubed and I did one round of synthetic division, my result would be an x squared, and then I can find the remaining two zeros in my quad program. So what I'm going to do is I'm going to put this in my y equals and see if I can eyeball it and find at least one of the x-intercepts. If I didn't have this, the way I would start this would be like that problem we just did on 14 and 15. Find all the possibilities of things that may be x-intercepts, maybe not, but may be, which would give us a ton because we would be using 56, which has a lot of factors as our starting point. Okay, so let's put this in y equals and see if we can eyeball it. So x cubed, x to the third, minus 57x plus 56, and graph it. And see if any of these x-intercepts look promising. They would look promising if it looks like they cross the x-axis at a whole number, not in between hash marks. Actually, they all look good, don't they? Where does this one look like it may be crossing? Looks like it may be crossing at +1 to me. You can also go to your table, because what do you know about all your x-intercepts? Your x-intercepts occur when the y is 0. So 1 definitely is an x-intercept, but let's try it with synthetic division. Try the 1. I'm pretty sure it crosses at 1, so let's try it. If it is a true x-intercept, you should have no remainder there. So let's write in, now remember, we did some of this in support. When we're doing synthetic division, what's in front of x cubed? 1. There is no x squared, which means what do I need to put there? A 0 for the x squared. What's in front of x? -56, and what's your constant?
I thought it was -57.
Oh, thank you. Just sitting there looking right at it. So let's drop down my 1. 1 times 1 gives me 1. I'll put that answer here. And then I'll add it down. 0 and 1 is 1. 1 times 1 again, which gives me 1 again. What's -57 and 1? -56. What's 1 times -56? -56. So this is a true. 1 really is a 0, right? It ended with no remainder. How can I now, if I started with x cubed, what is going to be left here? What's 1 degree below that? X squared, which is what? Quad. Then I'll be able to use the quad to find my other two zeros. So let's see, if this is x cubed, that means this is x squared plus x minus 56. Go to your quad, put in your A, B, and C, which would be what? 1, 1, and negative 56. There's your other two zeros, 7 and negative 8. So what was the first one? 1, 7, and negative 8. Go back to that graph that you just had. Just hit the graph button. Look, there's your 1. There's your 7. And there's your negative 8, right? Those are the three places it crosses the x-axis. 1, 7, and negative 8. So if you can't eyeball it, go ahead and eyeball it to get one of them. Oh, this one has one more step. So there are only rational zeros because there's no i's or square roots. So the only rational zeros are negative 8, 1, and 7. The second part of this wants me to write out the factorizations, which means what factors would those have come from? What would this one have come from? X minus 1. What would this one have come from? X minus 7. And what would this one have come from? X plus 8. So that would have been the factorization. Number 17.
16.
That was 16. Yeah, remember I didn't do 15.
Will we put the factorization on here?
Yes. So see that part right here? So you would put there are only rational, yeah, right there. So there are only rational zeros. Those are the zeros. The factorization is what you're wrong.
I'm lost.
I didn't do number 15. 15 was just like number 14. I didn't want to waste a bunch of time on that because it was just that same process. Yeah. So when you're doing your homework, use number 14 also to help you do number 15. It's the same process.
What about 15?
That's what I'm saying. I skipped it. I'm not going to do it. It's just like number 14. You'll be able to use number 14's example that I did to also help you do number 15. There's absolutely nothing different.
Okay.
So that what we just did was 16.
Okay.
Now 17, same kind of problem, but we're going to run into a hiccup. F of x equals 2x cubed plus 5x squared plus 50x plus 125. Now, remember, if we're lucky, we can put this in because it's just cubed, which means if I can do one synthetic division, I would get it to squared and then use my quad. But when you put this one in y equals, go to your y equals and clear it out, and let's put this function in. 2x cubed plus 5x squared plus 50x plus 125 and graph it. First of all, the only one I see is this one. And what's not good about where it's crossing that we did see on the last one? It's not on a hash, it's not on a good number. Right? It's totally in between two hash marks. right? Not going through a hash mark. Looks like it's going through somewhere between -2 and -3, but who knows exactly where that would be, right? So I can't use that to do one of the synthetic divisions. So I'm going to have to do something else. I'm going to try and factor this. And again, we did some practice with this in support. This is the kind of factoring I'm going to use. This is something that you don't see all the time. There's 4 terms, but there's not anything in common with those 4 terms. So there's no greatest common factor. So I can't use that kind of factoring. If there's no greatest common factor, but you have 4 terms, you're going to factor them by grouping. So I'm looking for 3 zeros, right? Because that's an x cubed. So let's see. Here's how you factor by grouping. In the first group, because if I can find the factors, I can turn those factors into zeros by solving them. Okay, so let's see. What's in common in this first group? How much of this x can I pull out? Good, 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 good. So I'm pulling out x squared, putting in parentheses what is left. So if I divide these both by that x squared that I pulled out, if I pulled x squared out of this first term, what's left? 2x, good. Plus, if I took the x squared out of this term, what's left? Just the 5. What's in common in the second group? What's the biggest number that you think probably goes into 50 and 125? 25. Right, so I'm going to pull out a 25. Divide by 25. What is supposed to be left in this second parenthesis? The same thing that's left in this first one. So let's see. When I divide this by 25, what's it going to give me? Good. 2x plus 125 divided by 25 is 5. So that's good news. So there's the factorization. I have 2x plus 5 as one of the factors. What's the other factor? What you pulled out. Good, good, good. X squared plus 25. So this one, if I solve that for x, it's going to give me a 0. So let's see, I'll solve that one for x. So 2x plus 5 equals 0. Solve it for x. So subtract the 5 from both sides. So 2x equals -5, divide by 2. So x equals -5/2. So there's one of the zeros. And remember where it crossed through on the graph? Between -2 and -3, but it was kind of, you know, just halfway in between them. What is this? What is -5/2? If you turn that into a mixed number, -2.5. That's where it's crossing, -2.5. So that's the first 0. Look at this other factor here. What does this mean it is? Squared. How am I going to find the other 2 zeros if my factor is x squared? Quad. So go to your quad. What's A? What's in front of x squared? 1. What's B? Be careful. 0. What's C? 25. What are your other 2 zeros? 5i and -5i. So there's your 3 zeros, -5/2, 5i, and -5i. Now, so that's the 0 part. So let's see, you would actually put in, that's why I only, remember when we graphed that? you only saw it crossing in one spot. There's only one rational zero, this one right here. It's not going to cross. Eyes are imaginary. Those aren't going to be x-intercepts. Okay, so the other two zeros are the other zeros. So you would check the B one. There's only one rational zero, which is negative 5/2. And the other zeros are 5i and negative 5i. Then the factorization. So I need to write the three factors, right? I have three zeros, so they come from three factors. These are, what would this one come from?
Minus.
Good. X minus 5i, what did this come from? X plus 5i. What did this come from? Well, just look, where did I get it from? That factor right there, right? That's what I solved to get that zero, which means the factor that negative 5/2 comes from is that 2x plus 5. Oh my goodness. I had some lofty goals trying to get through this and 8/5. 18. That's all we're going to be able to do. Last one. Same thing. All right, finding all the rational zeros and any other zeros. Last one, f of x equals x to the fourth minus 10x cubed minus 66x squared minus 94x minus 39. Oh my God. So this one's going to have 4 zeros. I'm going to try to eyeball it and see if I can get any of them just by eyeballing it. So I'm going to put this in my y equals, right? Because if I can do synthetic division, and I have no idea how to factor that, if I can do synthetic division enough to get me down to x squared, I'll be able to find the last two zeros in my quad. So let's put this in our y equals x to the fourth minus 10x cubed minus 66x squared minus 94x minus 39.
You need second graph or just graph?
Now, you could hit, I'm going to hit graph. You can hit second graph. If you hit second graph, you would be looking, all your x-intercepts will have a 0 in their y spot. So if you go to second graph and see a 0 in your y, the x that goes with that is an x-intercept. I'm thinking -1 and -3. It's touching at -1 and it's crossing at -3. Now hit second graph and see if there's -1. Yeah, its y is 0. -3, yes, its y is also 0. So I'm going to use -1 and -3. I know those are both zeros. Watch what happens. Use synthetic division. I'm going to have to rush through this as fast as I can. 1, -10, -66, -94, -39. Drop down your 1. -1 times 1 is -1. Go straight down. That gives you -11. -1 times -11 is +11. What's that going to give me? -55. multiply. -1 times -55 is positive 55. What does that give me? Negative 39. -1 times -39 is positive 39. So there's your remainder 0. Now I'm just going to roll this into the next synthetic division. Because -3 is also a 0. Because what would this, if I wrote this all the way out, if this was x to the 4th, this would start off x to the 3rd. So I'm just going to use those numbers now for the other synthetic division. Bring down my 1. -3 times 1. -3. Add this straight down. -14 times -3. Positive 42. Now add this straight down, I'd get -13. -3 times -13 is positive 39. There's my other 0 remainder. So if this started off with x to the 4th, its answer would have been x to the 3rd. If I did synthetic division again with an x to the 3rd, what's this going to end up being? Good, good. So -1 is a 0, -3 is a 0. There's 4 zeros. What can I do now? Quad to find the other last 2. So program down to quad. A is 1, B is -14, C is -13. We're decimal. There's your other 2 zeros. 7 plus the square root of 62. 7 minus the square root of 62. So you have the rational zeros are -3 and -1. The other zeros are 7 plus and minus the square root of 62. And last little thing, I need to write out the factorization. What would this one's factor be? X plus 1. What would this one's factor be? X plus 3. Here's where it gets weird, as if it wasn't already. Now, look at these. Your factors are always x minus whatever your 0 is. That's why it turns in to x plus if it's negative. So these factors are x minus the 0. 7 plus the square root of 62 and x minus 7 minus the square root of 62. So those 4 factors. I have no idea how I thought I was going to get to 8.5.